okay, we want to look at, quote, the normal curve or a normal curve, and what I'd like to have you know is normal curve, normal distribution is what generates what we call a normal curve. But the normal distribution follows the way things naturally have a tendency to occur, creates a bell curve. And the bell curve can have shapes like this, or like this. But they have other tendencies as well, but what they have with particular features. And the three that we recognize as important is one is a central peak. Number two would be even distribution, in other words, symmetric distribution. About, which is a word for around the mean. The mean will be in the center, which will also tend to be your median, and it'll even also tend to be your mode, but it's the high point in the middle. Very few values far from the mean. You might not have any that are very far from the mean, but what is far, right? But the more values you have, the more chance you have of having an outlier or a few outliers that are out there, but still, when you put all the data together, they tend to cluster toward the middle. We've heard earlier about the regression toward the mean. Values do tend to come around the mean and sit near the middle and fade off. So this is your bell curve, and this would be how we have things like, you know, you don't always want to have a bell curve applied when someone says, oh, I'm going to curve the results of this test. You don't always want it to be, yes, he's curving the test, because I can take you back to the first physics test I took when I got to college. Pretty much everyone taking physics 1 at the school I was in had taken physics 1 at least when they were in high school. And so they had taken this, all this stuff before. And what happened was, the first test, the mean was 97%. And so the teacher was thinking, if I put this on a curve, I can really just, separate who got the really good scores. And a weird thing happened with that. We'll see more about that a little bit later as I go further into that story. But this might be what's happening, but you don't know where the mean is, right? I mean, the mean for a lot of people, they think, oh, the high score is 100 and the middle is like 50. But no, we don't tend to have the average score of an exam be 50, maybe 75, maybe 70, maybe 80. But anyway, the mean is here. And then out here you got the people that did better than average, and down here you got the people that did worse. And you don't have a bunch of people way down here with scores like 10 and 20. And you don't tend to have many people up here with 95, 97. But if you had a normal distribution of data, it would come out into a curve that looked something like one of these two. We don't know how high it is, or how wide it is, or even where the middle is until we get specifics about our data, but the shape of the data is going to be this bell curve. Now, what we're going to go most intently with is this thing called the empirical rule. And the empirical rule of normal distributions it's got these three numbers. Now, I know them from having taught them so often, but it also supports what we saw in the rule of thumb, saying that almost all the data values are within 2 up or down standard deviations from the mean. Now let's look at how it goes. It goes like this. I like to think of it as 68, 95, and 99.7. And those are percents. And so what do we have? 68% of the data points lie between +1 and sorry, I should put the -1 here. -1 and +1 standard deviations of the mean. Next, 95%, which is almost all of them, of the data points lie between -2, 2 below, and 2 above, and it's all the same of that. And 99.7. And there are other numbers. You can go for 4, you can go for 5, but it gets ridiculous because so much of it is within 2. Maybe you'll care enough to say, all right, let's look at the 99.7 of the data points lie between -3 and +3 standard deviation. Now the thing is, when they said almost all, they're talking 95%. When they're thinking of this number, but they weren't even talking specifics. When they're saying almost all, they were meaning 95%, and that is a big number in statistics. 95% is going to put you at what we would call like a 95% confidence interval is common. That leaves 2.5% that's even higher than that, 2.5% that's lower than that, and that would be considered in many cases outliers because there's so few of them. Maybe not directly called outliers, but that might be where they are. Or maybe if you want to go down to this tight level where you have not even 0.3% on each end, but 0.15% on each end, that's outrageous to go with that. Let's go with 95% between plus and -2 and say, all right, let's figure there are about 2 standard deviations up, 2 standard deviations down. We're going to have almost everyone. So that's where the information came from that we had previously. So now what I want to do is take this and generate some information about something that's intrigued me for a while. And that is SAT scores on an 800-point section. We'll go ahead and take a look at that. And so here's the SAT score part. We're going to set up a curve that's a normal looking curve. And it's going to look like a bell. And it's going to come up, and it's going to come down, and it should be, it's not the worst bell I've ever drawn. I don't know if it's the best, but what we're going to do is we're going to go with the SAT score ideas. SAT section scores are supposed to be normal. So they say they're normalized with a mean of 500 and a standard deviation of 100. Now the funny thing about the SAT is they don't have to care or worry about how hard it is because they want to normalize and they want to say who's better, who's worse, and then use this normal curve to straighten them out. So what they did at least when I took the SATs, is you took questions, and in order to discourage random guessing, they took a little bit off if you got it wrong. They gave you 0 points if you didn't answer it, and they gave you a full point for each question you got right. They get your total raw score, they call it, and then they go ahead and figure out what the raw scores are, and they plot them in this curve, and then they start doing this. Here's the mean. Then we'll go out 1 standard deviation. That's to the good side. That's to the bad side. That's down. Draw from the mean. Do it again. Should be about the same width every time. I'm not perfect at doing this. Actually, I got room up here. We can do that. And then their concern is, you know what? Let's just do 3. Let's do that whole 99.7% of the data is between the red lines idea. Mean is said to be 500, so that's in the middle. And then standard deviations go up and down from there. So I'll go for green, and if you did a full step better than the mean, your grade would come back on that section as 600. Or if you were lower, would subtract 500 from it and get 400. It's tough. This was a really good lecture to do in front of an audience, but I'll do the best I can with it. Add another 100 to get to the next level. You got 700. Take another 100 off and you got 300. And then let's put another, and here you see 800. That might be a recognizable score. And here's another one, 200 might be a recognizable score. Why? Because SAT scores for a section range from 200 to 800. Why, I don't know. I mean, they didn't want anybody to feel like they got a 0. They certainly could have put the middle of this thing, if they wanted to go with the hundreds like that, they could have put the middle of this at 300. And they could say the top is 600 and the bottom is 0, but I guess people would feel bad about getting 0 on the SAT. So they said it like this. That's fine. Once everybody figures out what's going on, they know what 200 means, they know what 800 means, they know what the things in between mean. What they do is they take all the scores and they plot them so that a curve falls out this way and has a tendency to cluster toward the middle, and it does come out this way year after year. And then they would say, all right, where do the strips go? What does the standard deviation create? And if you got a score that belonged out on this wing, if you were in the, now I'm going to go to a number, 0.15%, if you're in the top 0.15% of performers, because we can take the 99.7 out of the middle, leave it with 0.3. But half of them are so bad they're down here, and half are so good they're up here. Half of the 0.3 is 0.15. So that's anyone that got that or higher got the 800. And then you got these, wherever your score fell in this pathway, got you a number that also ended in a 0. Because they also could have had the SAT, right? If they, instead of centering it at 500, centered it at 300, that's one thing. But they actually could have centered it at 30 and made the standard deviation, instead of 100, made it 10. And it could have gone up to 60 and down to 0. But again, you don't want people having 0. So they give you these numbers, and everybody feels a little bit better about the numbers. But it's telling the same story. And so what if you had a friend who said to you, oh, I got a perfect score on the math portion of the SAT. What do you mean you got a perfect score? His or her impression was that that person answered every question and got every question right, and that's why they got 800. That's weird, because why does someone who thinks they know so much about math not understand this? Because that's not correct. What it means is they got past this bar. It's an impressive score. It's as good a score as you can get, because it means you're in this upper wedge. Why is the person telling you this? I don't know. But some people will, and they'll think they got a perfect score. No, if they tell you I got an 800 on the SAT, why are they telling you that? But okay, they are. It means that they're up in that really high level of outliers with good scores on the math. But they might have gotten something wrong. If enough other people got one problem wrong or left one blank or whatever happened, so you don't know that you got everything perfect. But there you go. You've got your layout of what's going on. And so now, if someone's got a score of 750, something that you might, a school that's highly competitive said our median acceptance SAT score on the math is 750, it would be right here. So your math has to be there if you want to be sort of the average math student coming in their class. If it's 780, it's up here. But then you might find schools that have an average SAT score of 560, or even in some cases 480 for what they're looking for their average students. But let's say Harvard has an SAT score of 780 for math, and that's out here. They let anybody apply, but if you apply with a score of 360 on the SAT, there's going to be an indication to them that they're not sure you're going to be able to handle the workload that they have there. So that's what the SAT is about, to get people in regions. When people start saying, oh, my son got 750, and this person, mine got 760, there may not be much of a difference between those, but what they're trying to do is discern the people that are in the 750, 760 range, and say there's a difference between that and the people who are in the 320 range. And there probably is. They're not meant to say the difference between those little tiny bits, but to put you in a position of where do you fall in the range of this. And this is what goes on when we have the normal curve. But the thing about the normal curve is it's there for all of our data sets that are normal data sets. And therefore the shape of the curve will remain the same, and the 1, 2, 3 rule of 68, 95, and 99.7% is going to be in play all the time. So we're going to take a look at that one now, and we're going to look at some used cars that come in after 2 years of being out on lease. So we're going to keep the same curve up there because it's a normal curve. But now we're going to look at values that are placed on the returns of 2-year-old Ford Fusions. They've come in off lease, and they look at the mileage, they look at the condition and all that, but these are what they come in and what they maybe give you. Now let me tell you quickly about leases, and we'll do more with them later. With a lease, it's not a great idea for everybody. Some people think it's awesome because the payment is low, but the deal with a lease is that if you lease a car for 2 years, then you are paying off some of the car, and then you're giving the car back. So you're kind of renting it. Or if you want to look at it even more aggressively, you're kind of telling them to repossess the car after a couple years. But you're doing it peacefully, and you're not getting a bad mark on your record. But what you're doing is maybe the car costs $25,000, and then 2 years later, you're going to give it back, and you're going to say that it's worth $10,000 to them, and you will pay the difference of the $15,000 plus interest and wear and tear and all that. So you're renting the car. You might think you own it, but a lease is really just something you do in agreement to buy the car initially, with them having the opportunity to take it back from you, and you stop paying. Then, if you owe $10,000 on the car, and you're like, I don't want this car anymore, you'll stop paying and you'll give them the car. Or you're like, this is a pretty good car, I like it, I'll buy the rest of the car for $10,000. It's based on mileage, wear and tear, features, price, how many months you lease it for, and all that. Okay. Well, let's say that the lease returns of 2-year-old Ford Fusions. Now, this should not have you thinking, oh boy, I'm going to go out and buy a $25,000 a year Fusion, only 2 years old, and get it for $10,000, because even if they return it for $10,000, then the dealer will clean it up and fix up a few things on it and put it on the market, out in the lot to sell used for probably somewhere between $13,000 and $17,000, something in those round numbers. Maybe between $12,000 and $16,000 or something like that, because they make money on that too. And that's fine. If you don't like the deal, don't take it. But this is the deal with the Ford Fusion pricing. And these are numbers that I have so that we can demonstrate what's going on here. We're going to say the mean price is $10,500. If you put on a lot of mileage, you'll pay extra for that extra mileage. If you don't put any miles on and you bring it in, you're like, hey, look, I didn't bring any miles. You know what they're going to give you? Maybe a thank you. But they'll just say, well, we gave you the chance and you didn't do it. So don't expect to keep the miles off and get credit for that. It's all part of the business. The standard deviation will be $500. So now we can get going here. We got $10,500. And we've got variation up to $11,000. And this one would be to $10,000 because it's down. And they may have initially said that the car's worth $12,000 if you return it in pristine condition. We'll give you $12,000 for it, and if you don't go over the miles and all that. So now we look at this one, $11,500. And this one's lower, it's $9,500. And then this one out here, $12,000. And this one down here, $9,000. It's the same kind of pattern as we had for the SAT scores, the normal curve. Now, let's look at what we've got here. 0 means you're right on the mean. If you're a little higher than the mean, +1, -1. +2, -2. +3, -3. I don't know if there are rules about this, but if you bring in a car that's like brand new and has almost 500 miles on it instead of the 20,000 you were supposed to, they might consider offering you more than 12,000. They don't have to, but if you're about to buy it for the 12,000, they're like, wow, but if we get it for 12,000, we can sell it for 19. Who's to say they won't say, you know what, I really like yours, I'll offer you another 500, and that might put you over this, into this range. There were 10,000 cars, we'll say. Let's see. In order to go with numbers of what we have, assume 10,000 cars total across the country. Okay, we're going to look at 3 questions. How many came back between 10,000 and 11,000? And I'm not making fun of the Ford dealers, but I'm saying that if you're going to get the 12,000 that was initially promised, that car's got to be perfect, and few cars are viewed as perfect. But you thought you were going to get 12. What's the likelihood that actually what you got offered is between 10,000 and 12,000? I'm going to go with the green marker on this to focus your attention on where we are. Oh, look at that. The green marker actually has a 2 on it. Anyway, we don't want to. We do have 2 spaces, but we want to be between these ones. We want that one and that one. So we're going between plus and minus 1, and that's 68%, because that never comes off the normal curve, right? If we got plus and minus 1, we've got 68%. We've got this other one between the 2's, 95%. This is the empirical rule. Empirical means it should be able to hold up. Plus and minus 3 will get us 99.7%. There may come a number that eventually reaches 100% of the 10,000 cars, but this is the normal curve, and this is what the empirical rule does. How many cars came in that way? We're going green. 68%. So we want 68 out of 100. And then we want to multiply that by the 10,000 cars. We get 6,800 cars. We're going to land with prices, if the deal has always been 12,000, between $1,000 and $2,000 less credited to the person. So they got to make up that difference. If they thought, here, I'm going to drop off the car. If you're down here, you thought you were getting 12 and you're getting 10, you owe them $2,000. That may encourage you to buy the car, continue paying for the car and keep it, or pay the $2,000, or get a new car, a new lease, and put the $2,000 that you're behind into the next lease. All possibilities. But what we had was this green region, these 2 strips, 68%, pretty much 34 there, 34 there, 68 because of the balance on each side. Less than 10,000. How many were less than $10,000? Now remember, it was a $12,000 offer initially. So how many people came out owing more? This was 68% than 10,000. Now let's look at what we want here. We want to be down here. We want to be this thing. I could fill the whole thing in, but you see it, and it'll be easier for you to erase it later. Okay, so what we have is we want to get that percentage. And how can we do that if it's split so evenly, right? This is 68, so these are each 34. That's half. And 34 lies on this side of the green. So we can say we've got 50% on this side of the black, and 34 is above the green line. We want everybody else. We want the complement of that 50%. So we're going to go with the lower 50% minus 34% leads us to 16%. And then we'll go with 16 over 100 times the 10,000 cars. You get 1,600 cars. Now there are multiple ways you can do that, right? You could take the 100% and strip out the 68. Pull out the middle. That'll leave you with 32, but half is on the left and half is on the right. Half of the 32 is above, where would they be? Above 11,000. And half of the 32 is down here where we're looking, below. You get 16%, and you find that out to be 1,600 cars. And that includes every car down here to the one that they basically are like, whoa, you gotta buy this car, because otherwise you're gonna have to pay us, I don't know what you're bringing in, a wrecked car. You gotta pay us $9,000 because it's only worth $3 or something like that. I guess it could happen. Maybe you piled on the miles and it's all dinged up and all that, but basically you're not out to rob you, but they have deals they have to make and they have parameters they have to adhere to. Over $12,000. Let's realize that they offered you $12,000 as the plan, and they said that's all you're going to get. But your car comes in, it is so amazingly clean and untouched, and it's got almost no miles on it, that it's practically a new car. More than when they say it, it actually really is practically a new car. And they know that while they're selling new Ford Fusions for $25,000, that with this one being like that, they could probably make a really quick sale of it at $19,000 or $20,000. So they can give you a little bit more and still make some money. And they're interested in that. So we'll come along with the blue, and we'll look at this one. It's a small wedge. Now, you saw I did that with 50,000. I want to represent this last one. How many were over $12,000? Let's start with the 100%. And let's subtract what's between the reds, which is 99.7. And that's going to get you 0.3%. But then we got to cut that in half, because half is really good above the 12,000, half's really bad below the 9,000. And that's 0.15%. So what's that? That's 0.15 divided by 100, and then times the 10,000 cars. That's not 15%, not 15 over 100. It's 0.15 over 100. It's 0.0015 times 10,000. That's 15 cars. Out of 10,000 cars, there might be 15 cars that get their attention at that level. So this is how we'll work with what we call the empirical rule. And we'll do work with that. And you'll see some in the book where they say, here's the mean, here's the standard deviation, and I want you to determine how many cars come out in this range. And the range will be landing on particular values that land on these medallions here. And that will tell you what you're between. Are you doing 68? Are you doing 95? Are you doing 99.7% of the cars, or whatever you're measuring? And then you'll go find out that percentage of the number of total units that are in play, and you come up with the expectation of how many land in a particular range. So that's how this rule works, and that's what one of the things that the normal curve can do. Now, all these values along in here are available using the normal curve, and they used to be in tables, they still are, or on calculators, but we're not getting into that much detail. We're happy with the empirical rule showing us some of the ways that these things lay out on the normal curve. Now I've got another bit of information that I want to work out with you. And that's percentile and rank.